Without further ado, I would like to invite our esteemed dignitaries on the dais. Please come and occupy the chairs. Shri J.B. Suhag sir, Shri Paresh Haribhakti sir, Shri Dhuval Kumar sir, Shri Ashwini Mishra sir, Shri B. Sai Kumar. Please come upon the stage and occupy the chairs. Please have a huge round of applause for dignitaries. I request Mr. Jayesh Joshi to welcome our moderator Shri J.B. Suhag sir.
अच्छा केतन
Mr.
तो नाम चेंज करवा दो ना यार. चिराग भाई हमने नाम चेंज कराए थे परे सब.
Mr. J.B. Suhag is a mechanical engineer and first-class boiler proficiency engineer from Gujarat Boiler Board, currently thermal power consultant and earlier associated with RIPO Industries Limited as a Vice President, Western Region. Now, I request Mr. Ajit Modi to welcome Ashwini Mishra sir with the memento and bouquet. He is Vice President at Gallant Ispat Limited, Ahmedabad. With 27 years of experience in thermal and captive power plants, he has held key leadership positions including Head of Power Plant at Electrothermal and PCBL. Now, I request Mr. Anas Sheikh to welcome Shri Dhuval Kumar sir. He is competent person for inspection and certification of boilers, certified lead auditor for ISO, Energy Management System, certified BOE trainer and BOE engineer. Now, I would like to invite Mr. Chirag to welcome Shri B. Sai Kumar, Executive Engineer, ONGC Hazira Plant. Now, I would like to invite Mr. Jayesh Joshi to welcome Mr. Ketan Upadhyay sir. Now it's time to hand over the mic to Shri J.B. Suhag sir, our session moderator.
Good afternoon, everybody. I think this session is very much after lunch. It is very much means tidy for everyone, and I saw that 50% seats are empty. So better you come forward. So at least this much will also remain up to this session. Otherwise, the last one, please come forward. We have to fill the seats. Please come forward. So this session, sustainable practices in boiler operation. This is the main session of the new innovative session for everyone. In which first session, first topic is being covered by Mr. Hari Bhakti, but he is not there. So Mr. Chetan Upadhyay will take on over for the TB. Transforming boiler maintenance by decoding damage mechanism. Then Mr. Dhaval Kumar Khamar, he is also take the digital business and strategy for Marshal. Then Mr. Ashwin Misra, that is waste heat recovery and energy efficiency in boiler system. And lastly, this corporate presentation by Mr. Bhupesh Patel, ONGC Limited. So I would like to invite Mr. Chetan Upadhyay to start this topic, transforming boiler maintenance by decoding damage mechanism.
Respected dignitaries, friends, first of all, I thank you, Steamtech, for giving us this opportunity to present something which is going to be interesting to you. This session, I just had this last week, and it's like 3.5 hours of this total topic. I have squeezed it to 15 minutes, and you will appreciate that. It's like running in very fast, but if you have any question, any problem, you can always come back to us and write back. So this is the session regarding reactive to predictive, like something which is you are reacting against something, against which you are predicting something for something. Okay, so that is what it is by transforming the decoding or understanding the damage mechanisms. It is very simple, easier said than done. However, I know what can go wrong with my body. Okay, I can have fever, I can have headache, I can have stomach upset, but exactly at what time what happens can only be said or diagnosed by a medical doctor. So similarly, these damage mechanisms are there and those damage mechanisms are to be understood well by all of those who are involved into boiler operation, maintenance and even design. So what are the factors which are causing the failures is very important to understand. It's like life limiting factors. Sometimes they are incidents of accidents. The first and nowadays which is of prime importance is renewable resources of energy. We understand solar power. It's very good, but solar energy comes in the morning till the evening. The problem is that the boiler goes down in the noon part, and then it goes on the peak at the evening, then it again goes down in the night. So this is not for which the boiler is designed originally. Okay, turbine may be designed for that, but the boiler operation to a level of fluctuations from 30% to 80% or 50% to 90% or 100%, sometimes more than 100%, is very, very challenging for operators. So that is one. Second point, there are certain inherent design or fabrication issues which are generally taken care during initial period of the commissioning period of the boiler. Then there is a problem of fuel quality and flue gas side damages. Fuel quality is not in your hand. You can't get the fuel from the resources that you like. You may have to choose, like in the morning session we understand biomass. Now you have to use it. It's compulsion. So 10% addition, 20% addition, 30% addition. What will it make to, like in damage accumulation to the boiler components? There are various boiler components. It's not one or two like tubes, drums. No, there are so many things which are happening or going wrong in any direction. If you don't know what it can cause wrong. Second, then there is boiler operation related problem, which is feed water treatment. You are all experts into that. I don't have to tell anything about it. But tons and tons of the feed water is used, and so many different types of chemical agents are used for controlling the quality of the boiler. Ultimately, whenever the water evaporates, it forms from H2O water liquid to steam vapor, and that leaves behind all residue, the solids, TDS, whatever is there on the wall of the boiler tube itself, and that creates the problem. And there are so many other related aspects which are causing the damages to the boiler tubes. Then material of construction and its deficiencies. Sometimes we have referred like there are Chinese materials. So Chinese materials are not good is one image in our mind. Sometimes they are good, but then all it depends on the L1 criteria. So the cheaper the material you buy, there is a probability of low grade quality or material not qualifying to exact requirement. Sometimes the exact requirements are not raised. I am giving you one example at this moment, is that if you are ordering 347 material for your superheater, 347H, 316 HFG, so those type of materials are to be specified to have stabilizing heat treatment in your purchase specification. If you don't go with that, then they will taken as granted. Okay, you have not asked, we have not given, and those materials were having carbide precipitation, sensitized condition. It is as good as carbon steel. So your stainless steel doesn't serve the purpose. So specifications, purchase specifications is also one of the important aspects in material of construction, its deficiency coverage. Then there is aging related problem, degradation of the material and the creep damage. This is a very well known bathtub. It's like age is old, maintenance bathtub. Nowadays it doesn't hold true, in the sense certain problems which were appearing in the initial period of the boiler operation or commissioning stage, once they are taken care, they will not appear or reappear, and you are eliminating those type of problems forever until the boiler ages. So there is a steady state smooth operation part after 3 years, 4 years, or maybe like 2 years, and then continue up to another 15 years without any problem. But the power fluctuations, the load fluctuations, the demand, the use of different fuels, the mixture, the type of burners, now there are so many technology upgrades, and people they just come and sell some product to you, convincing some management with respect to cost, and you are changing certain burners, you are changing certain fuel system, the IDFD fan draft systems. There are so many things that keep on changing, and those are creating further challenges even during the straight portion what we see over here. So what is the intention is to convey here is there is a difference between inspection which is done as reactive. There is a failure, you understood the failure by getting it investigated, why it failed. You had that remedial actions readily available now, and now you are inspecting. But that is one. The another thing is that am I audible now? Thank you. Another problem is that if you are having sufficient knowledge, if you have sufficient knowledge where to inspect, how to inspect, and how much places to inspect, okay, which are those different areas where you can inspect, then the scenario will be quite different. So that is predictive or proactive inspection strategy. I am just showing you one of these examples. Unnecessary over inspection, that does not always ensure the safety or elimination of the failure. What we are doing is thickness measurement. What is IBR requirement? Do conduct RLA. What RLA does? We are one of those remnant life assessment agencies approved since 2014. What we do? You know, we are doing these thickness measurements, MPI, UT, and wherever there are flaws, they are getting repaired. So what are those parts are to be inspected? What are those parts and what are those components and what are those finer areas where you have to inspect in that particular pressure vessel? For example, drum. Where exactly you have to inspect so that the failure won't occur? Lies with the knowledge that you are having based on your past experience. So if we have 10,000 points of thickness to measure on tubes, against which if we have only 1,000 points but very critical, those which are only essential, if we know those points, which are those points? Those points you all understand. Those points near the bands, those points which are facing the flue gases, which are having certain shields, and those shields are damaged, then there is a probability of failure of the tube on those regions. Having known this, if you can't implement that, or if you don't implement, then it is a reactive type of inspection, which is not good. What you have to do is apply your knowledge and do a knowledge-based inspection. If the knowledge is not sufficient, we can get it, we can read it, we can attend the seminars, and we can experience finally through failure investigation. So there are reliability assurance through KBI, that is knowledge-based inspection, which is profit is linked to reliability. Everyone agrees to that. Necessity to maintain units always online, okay, that's your reputation, and that is way you are profitable. Unplanned outages or extended turnarounds, okay, that will cause severe financial impacts, and failures, if any, will result into safety consequences. And sometimes, you know, in refineries especially, the boilers which are operated in captive power requirements in refineries will cause shutdown of those units which are otherwise very critical. So this is a kind of damage mechanism slide I have prepared, and these damage mechanisms are so known, but they are also not known, in the sense that you know these by names, but you don't know sometimes that how actually it will affect the equipment or the integration of the boiler. I have touched upon some of this, not all of them, this beyond the scope of this time limit. So just understand what is the scale. In fact, corrosion is preferable. Corrosion is preferable for boiler tubes. Why? Because it forms a magnetite layer. That magnetite layer doesn't allow any further corrosion of the substrate, that is the parent metal, or within that. If we are operating the boiler tube under 570 degree for this critical condition within half an hour or so, if we are increasing the temperature more than 570, you can see this change in the magnetite layer, which is Fe3O4 versus Fe-augustite. That FeO increases by leaps and bounds within a very short period if the temperature increases. When temperature can increase? If the boiler tube is facing certain starvation, if your upsets are there, if flow is not controlled properly in all of those tubes. So you know these situations, but having known that, now you also can judge my magnetite layer in certain areas might have affected. So during next shutdown or whenever the opportunity is available, you will inspect more on those areas rather than the areas which are not probable. That is why it comes like knowledge based inspection, right? So that is what you need to know. So this is what one example. Now this is the scale which is not preferable. Such type of scale which is very porous, amorphous in nature, it should be very very thin, like 20 micrometer is sufficient for all corrosion related problems, but we cannot maintain it. It then keeps on increasing. So we have these scale measuring units, the oxide scale measurement, internal oxide scale thickness measurement units available. We keep on monitoring, and wherever it exceeds like 300, 330, 340, it's a high time to do descaling either by chemical cleaning or something. But what happens if the thickness increases? This is the type of scale that it will form. It will retard the heat transfer. Our output in the boiler in particular section of the tube is that I want to achieve temperature of say 400 degrees Celsius, and for that 400 degrees Celsius, if the scale thickness is increasing, then the heat transfer gradient will be high. If the heat transfer gradient is high, what we need is to fire more and more fuel on outside by another that much degree Celsius temperature increase, so that we can compensate for the output. Otherwise DCS system will not work. In turn we are losing the efficiency, and in turn we are also creating high metal temperatures on the tubes. High metal temperatures relate to obvious creep damage or material damage. So we are actually decreasing or sacrificing the tube life as well. So there are various entities. I am just giving you the glimpse that has been already discussed by Hertz again in the previous session. LPT, we all know, liquid penetration test, where you can do on all those components, and it detects only surface flaws. Second is MPI, magnetic particle inspection, or fluorescent wet magnetic particle inspection. So that can also be done on all the surfaces for ferrous materials. Okay, and we can detect up to like 2 millimeter subsurface crack-like flaws or something like that. But high surface finish is required for that. We can do the ultrasonic testing on the weld joints, either on tube to tube joints. We can have a Cobra scanner, and they will assure the quality. What are the applications are there, but what are the limitations is that you need high level of skill. You need ethics. That is the most important thing. Any person who is inspecting must have good ethics. If we are going only for LPT and only spray the developer without, what is the purpose? We don't want to take a photograph with that shell. No. We want to ensure our fellow citizens to be safe. The boiler drum should not fail. And that should be the ethic that should lie over here. For every inspector who is doing that, every contractor who is doing that, and every person or coordinator from your side, they should also keep an eye on, check on it. Next is that radiography. Radiography can be done for choking condition, for profile radiography and other joint conditions. Again, the defect sizing and all those things are very limited into radiography. Eddy current testing for downcomer lines, RFET, eddy current testing for exchangers, those things are very well known. And there are limitations with respect to eddy current because high level of cleaning is necessary. Iris also is the same thing. Iris is generally done in the downcomer lines wherever the band is permitting the probe to go inside, and it will give good measure of the thickness on the band region. Another thing is replication or metallography or microstructural examination. So that microstructural examination will give us the condition of the steel for its degradation. Once we know the degradation, we can also judge the degradation rate. We know the degradation rate, we can also judge what is the possible degradation in the future, so remaining life. This is how it goes. And the scale thickness measurement, I already explained you, that will give us remaining life. So what is the effectiveness of the inspection? Is that like highly effective inspection is inspection will correctly identify the actual damage mechanisms for every instance that you are doing. Likewise, usually effective, fairly effective or poorly effective, and there are certain instances where ineffective. Those type of inspections are obviously not of any interest. I am just giving you effectiveness of the inspection with respect to slides or different types of instruments which are available. The picture which shows on the tube is like a Cobra scanner. You might have seen this in your field. It's a very accurate type of scanner that gives any defect in tube to tube joint, especially on the superheater bimetallic joints. They are very critical and those are to be assessed. So ultrasonic testing by PAUT, phased array ultrasonic or time of flight diffraction, that will be adopting this type of scanners. We know that in one of the instances I had witnessed, in a header there was a helmet inside the header. Fortunately no person was there, okay. But thing is that there are electrodes which we have found in the headers. There are so many other things which we have found in the headers, and those things are not directly visible, so we have to do remote visual inspection. This is nowhere written in the IBR code that you have to do it like this or that, but this is the knowledge based inspection. You know that this type of things can happen, so you use this. One of the joints may be cut, you insert the boroscope and check it, then you seal it. But you are ensuring that no clogging will occur on any single tube by this type of method, and no starvation will occur and no tube failure will be there. Okay. Likewise, there is hydrogen damage which is possible. It is also referred to be HTHA, high temperature hydrogen attack. So
Mr.
those
Ketan,
type of,
please.
2 minutes. So this is how you check for microstructure, ultrasonic backscatter. Then there is velocity ratio measurements, and there is PAUT method nowadays. So those are the things which are good for ultrasonic hydrogen damage assessment, and oxide scale we already have talked about it. So what are the benefits of knowledge-based inspection? NDTs has become more effective. Inspection coverage, which is susceptible locations only, depending on the anticipated damage mechanisms. Identification of potential damage mechanism is also one of those knowledge-based inspection. And trend analysis can provide correlation to key process parameters with proposed process changes, reducing the degradation rates. Once we know, we can also reduce the degradation in future, so that we are lengthening the time or life of the component. Then operational limits can be set, like we know temperature should be controlled like this, or wherever it is required the flow should be controlled like this, based on this knowledge based inspection. Documentation of current plant configuration and material of construction, and of course improved team working and planning, these things. So we have one software, our own software. It is asset integrity optimization and management. So that software incorporates so many things. Suppose one of these examples, you are stuck with one joint where there is a header to, like outlet header, superheater outlet header to your stub end joint of the tube. This metallurgy is like 3478, the header is P22. What electrode you should use, what should be your WPS? If it is not handy, always the management is shouting on you, you don't have the time. This type of software have readily available answers that these are the electrodes for you. So use of knowledge based inspection with computers, like Industry 4.0, what it says, you should have everything on touch of a button. If it is available, you go with that and you will save the time and you will be doing this job more accurately. So this is just giving you the glimpse of that. Mr. Paresh Haribhakti, I am representing him. My name is Ketan Upadhyay. Mr. Paresh Haribhakti is author of this book. This book, which is Failure Investigation of Boiler Tubes, is published by American Society of Metals, and it is on sale, even live on Amazon. You can find this very interesting if you want. But the point is that so many investigations and boiler RLA we have done that we could publish a book like this. Okay, and based on that, there is another chapter that ESM sent to us for review, that is the failure of boilers and related equipment. So this has also been reviewed by us, and our name is there onto that TCR advance, you can see, and this is also published in the latest edition. Okay, so thank you very much for your patience. Should you have any query, you can note down my number over here. It's not like business. You can call me anytime. Whatever extent to best of my knowledge, I will reply to you. Thank you.
Thank you, Mr. Ketan. Now I would like to invite Mr. Dhruval Kumar. He is the head business for foam marshal. Please.
Internet is connected. Yeah. Good afternoon. All this speaker after lunch, I think, have a moral responsibility to awake everyone, and will also do the same. And it has been always pleasure and honor to represent Forbes Marshall in this forum. Steamtech Forbes Marshall is associating with Saket Group and Steamtech with very beginning, and it is very critical and important forum for all the steam users. And Forbes Marshall, in a way, synonyms in a steam. It is very important to have to not only discussing present trends, but we are also looking forward for the today and the going forward, what is the trend and thing. The topic of today is again buzzword that's called as sustainability, but I think while going on we'll see it is not a buzzword, but it will relevant in this industry market for at least 1 and 2 decades going forward. So we'll deep dive in the topics. With this, start with the what all the key performance indicators, KPIs at present industries are facing and industry are noting. So gone are those days where we only talk about steam, only talk about the electricity. I think this is based on the study what we have in various industry. There are 3 major aspects at present as an industry they are looking for. First, as an energy as a whole. it includes thermal, electricity. It is very much important, relevant, and it is also having a mass into it. Second is the water. Again, by means of water, we always look after water as the cheapest thing, but in today's context, water is the costliest one. And third and important is the environment and the emission. I think environment is now an integral part of any industry's business. It is now no more choice and no more options. I think environment and emissions are more relevant, and it will be going a more strengthened in a going after. So what I'll show you the variation in the various industry. The animation, now you are seeing the new upcoming any design plan. So in this thing, wherever the plant we are having a putting up a new based on certain but detailed assumptions. If you see, the capacity of the plant is 20 ton, but even after 9 months the plant is running 40-50%. There all the KPIs, whether it is specific, steam consumption, condensate recovery, all these KPIs are deteriorating drastically. So you will think that okay, the new plant having a will not run from the day one, but it is all equal applicable for the existing plant as well. What we are looking here, I think. So this is the data of the existing plant, and I think for the variation aspect, if you want to see the variation in the present of your plant, take a data of the series of the days or hours. I think we talked in the morning and the previous session the very important of the data. This graph, the orange and the yellow color, showing the trends of the production and the steam. The variation in the steam and production in the range of 25 to 40%. But if you see many of the days where the steam production remains same but steam varies, and the overlapping curve is representing specific steam consumption. So even in the same production, there are many times when steam is deteriorated and it is not up to the efficient level. The another aspect, condensate recovery. I think along with the steam, condensate is a very important aspect because it is a purest form of the water, and condensate recovery factor, when we log the data on the real time basis, we see there is a huge variation in the condensate recovery factor as well. Third important aspect is a feed water temperature, and I think in today's world, to getting a data and getting a real time data, it's not very difficult. This is again representable of one of the site. When we log the real time data, the feed water temperature is also varied. So variation is happening across, and I think before 3-4 years we ourselves are not knowing so much variation is happening, and that's why performance is getting deteriorated. Furthermore, when we deep dive what is the variation and what the root cause of the variation, we understood 90% of the variation can be controllable. Means how? There are 3-4 basic things which we can practically do, and that variation can be managed. First is the operating practices. I think all the plant has a best of the operating practices in terms of SOP and all, but here I mean to say operating practice ensure to follow daily basis. Another aspect is the competency, and the competency means ongoing learning skills. That is also a causes of the variation. Third is the performance uptime of the asset. Again, asset working on off is a secondary matter, and performing is the secondary matter. There are many closed loop thing. Just an example of steam trap. By looking the steam trap, you may not know it is a working or not. But by having a thermographic gun and the instrument like that, then only you realize that steam trap is not performing. So asset uptime is another critical aspect, and fourth is a lack of monitoring. So if we have a 4 proper managed in a sequential wise, I think variation we can surely avoid, and that's why we derived a very specific and integral service model wherein we partner with the customer. This service we called as a service for sustainability, because we start as a sustenance and sustainability aspect, but we end up with the fact that every plant needs to start improvement first. Because when you look at the data of the plant and the whole aspect of the variation, we feel every plant will need to be improved and then sustained, and that to ongoing basis. Forbes Marshall has an domain expertise, plus now have a real-time data monitoring. We can able to manage all this KPI of the proper efficient steam systems. That is a generation side, we can know that steam to fuel ratio or boiler efficiency is one of the KPI. Condensate recovery factor is another KPI. The third is specific steam and water consumption. These all are the KPI we can monitor, manage. But another crucial and important aspect is the safety, environment, O&M practice and efficiency. Those all are parameters we are continuously improving and sustaining. We also realize that the benchmark of that particular industry and benchmark of that plant is very different. Example of the paper industry benchmark may X, but for that particular plant, that plant can achieve 1.2x as well. So in this service, we start with the re-establishment of the benchmarking possible with that plant, and then whole real-time dashboard and engage mechanism we developed. And what we realize, I will give you a few examples. And before start, as I made mention, we start with the real-time data. Just I think in the morning session, Mr. Akele described the real-time thing in the boiler. Because of the data getting real-time is not a tough or not as the costliest thing. We start with the getting a real-time data. Again, getting a real-time data is not seeking a real-time thing, but having a transparency between us. Again, you yourself realize when you take a log data and you report to the plant, there are always adding a factor. Here, by having a real-time data, we are knowing the fact, trust and the transparency. So start with the real-time data, and most important, applying the domain expert knowledge. That is another, because more data create a more complexity as well. So we add our domain expertise and that daily engagement with the customer. Again, this is not a consultancy thing. We are responsible for the improving outcome, that is a KPI. So this model we worked, and in a plant there are 3 layers of the things. First, bottomest level is the product level. So given an example, in the boiler, if you have a stack monitoring device which directly gives a SOx, NOx or SPM detail, that called as a product level. Further above, that is a equipment level, there where we can improve the operational level efficiency, that is boiler itself. And third, plant as a whole. So there are 3 layers of the things, and we can impact operational level efficiency, uptime and the steam and condensate both. We'll give you a equipment level example first. And I think this customer, just you all have seen the Suryodaya textile, which they got the order, they got the award for the best managed system. Last entire year through our engagement and the digital sustenance service engagement, we able to reduce their fuel, their steam and then water. And you can see the month on month improvement in each of the KPIs. First we define the KPI, we make a baseline, and then systematically month on month we work on improvement. Again, there are many things we'll later on discuss, but because of the daily engagement, it make a lot of difference. It is not the case they have a best of the product, best of the system from the earlier elsewhere. But because of the domain expertise, I think all these things, and it is a substantial saving. This saving would not give only with the products. So this is the reference later, and the third column, if you see the last year baseline data and the last 3 rows, specifically steam, water and the condensate recovery factor, if you see month on month they progressed. Again, variation happens, but the benchmark level and baseline level is so much wide, we can have a furthermore this thing. So overall they reduced 13% in steam, 24% in water and improved at 15% condensate recovery factor. So, and that's why we awarded them. But again, there is a continuously improvement within their side as well. This is not a one side activity which we are doing. Another example which correlate most of you, that is a boiler efficiency example of a food plant near to Ahmedabad, wherein there were 2 boilers, one briquette fire and one gas fired, and naturally briquette fire steam cost is 1/3 of the gas fired. Total load, steam load, they are having a 12.8. So typically 13 tons per hour steam they want, and this is a real-time graph what both the boiler they are running to cater 12.1 tons per hour. When we get a data as a real time, and then we see all the combustion parameters, how we can further optimize it. We did discuss with our domain expert team, and then we started fine tune how we can optimize for the briquette fired boiler, so that briquette fire 11-ton boiler can produce a maximum steam. And you see, this is an earlier scenario wherein briquette steam produced 8.6 and gas was 3.4 ton. And now when all the fine tunings has been done, at first stage the briquette produced 9.2 ton, and furthermore at step 2 briquette fired boiler produce a 9.8 tons per hour. So it is a substantial switch, and again this has not been a rocket science. We did a foundation step only, fine tuning combustion parameters, and then slowly gradually moved this boiler more efficient, and they got a 1 lakh per day saving because of that. You can see all the parameters, oxygen, CO, direct, indirect efficiency, all within the range. Another example of FBC boiler. Here where we install our boiler automation system, and then customer got a benefit. This is the Ultra Denim Surat case, wherein by installing the FEMAX system, boiler automation system, they improve boiler efficiency, but over the years the efficiency has deteriorated as well. Through ongoing engagement and the real-time data, again those combustion parameter in line, but we could substantially reduce the on-off cycle that is happening day in day wise. And you can see the reference later from their side, where parameters like oxygen and furnace, it is in very the narrow band. And now with the technology we apply machine learning and artificial intelligence, so then it can further optimized. This is one example of the paper mill, where with the paper has a steam is a very important and critical aspect. The board paper mill has a ratio of 2 kg steam per kg of paper, and then systematically we can reduce up to 1.7, and that leads to 1.5 CR saving. Again, in paper there are many control valves, the control valve controllability, the uptime, it is very important. And through systematic journey we can optimize all this aspect, and ultimately resulted into the proper saving. Again, why it is more important? Because it directly impact the profitability aspect. In the profitability, when we reduce the energy, when we efficiently optimize the process parameters and the environmental aspect, that is CO2 footprint and the water sustainability, all these impact a larger profitability. One more aspect, when we see, it is a cultural change within the company as well. Earlier also we have a product, we have a data, but now when we combination of the data plus domain knowledge plus directly ongoing engagement, I think we and customer both are in the journey of the ongoing improvement, and there we see a cultural shift within the organization, within our internal and the customer aspects as well. And that's why we called this as a service for sustainability. So we started with design benchmark plant. We are partnering continuous with the implementation of the benchmarking plant, and we remain with the sustaining aspect. So far we have associated with more than 500 plants in that such a aspect, and it across industry, not only one. And I think because we have a sort of domain expertise, and with the help of the real-time data, we are having into ongoing improvement in the sustainability aspect. I think any of the question we can have later on, but going ahead as well, if you can reach out us, then we can also do analysis of your particular plant with particular variation, and then how further we can improving and sustaining the KPIs. Thank you very much.
Thank you, Mr. Duval. Now I would like to invite Mr. Ashwin Mishra. His topic is waste heat recovery and energy efficiency in boiler system. પાંચ સાત મિનિટ તો શું આપણે સમજીએ.
Dignitary and decks, distinguished guests, managers, engineers and operators. Today we are going to discuss the topic waste heat recovery and energy efficiency. First, waste heat recovery. What do you mean by waste heat and what is recovery? Waste heat means heat which is going waste or heat which is going to atmosphere, that is waste heat. And if you recover that heat, then it is waste heat recovery. For example, take example of sponge iron kiln. In sponge iron plant, iron ore is fired with coal, and main purpose is to DRI, means to produce sponge iron. But in this process, CO gas is generated and a lot of heat goes to atmosphere and wastes earlier. Now, when you capture that heat and put boiler, you can generate steam even at very high pressure, say 110 kg pressure, 525 temperature, and can generate power. So there are so many sponge iron plant even in Kutch. Similarly, carbon black plant. In carbon black plant also, main purpose is to produce carbon black. That is for tire. For that, you fire CBFS, carbon black feedstock. Main purpose is to produce carbon black, but during that process also, heat is generated and a lot of gas, which was earlier going to waste, but now we put a boiler and capture that heat, produce steam and generate power. So if you recover that waste heat, then it is called waste heat recovery. And if it is boiler, then waste heat recovery boiler. Now, efficiency means in terms of boiler efficiency or power plant efficiency, what and how we can increase the efficiency. I have some 10 points, important points that will definitely increase your efficiency. Even if you implement one point, then it will increase your boiler efficiency, power plant efficiency, that is sure. First point, so every 22 degrees centigrade rise in flue gas temperature, reduce your boiler efficiency by 1%. Means, if you reduce your flue gas temperature by 22 degrees centigrade, then 1% boiler efficiency will be improved. Means at least 1% coal can be saved. If it is fuel is coal, then 1% coal. That is very huge. Even 100 ton boiler, if you save 1 ton coal, then it is 7,000. If it is a 1,000 ton coal consumption boiler, per day 1,000 ton coal consumption, 1% means how much? See, per ton 7,000 means saving is enormous even if it is 1%. So, how to reduce 22 degrees centigrade temperature from your stack, or is it possible to reduce? What is the design temperature of your stack? Say, if your design temperature is 140 degrees C and your stack temperature is 180 degrees C, then you have possibility to reduce the temperature. Then how to reduce the temperature? First thing, to keep the heat transfer surface area clean. During shutdown, you must have to clean your heat transfer surface area like boiler bank, boiler bed coils, superheater coils, economizer, everything. Either through hydrojetting or through mechanical means. Then, during running condition, you should have soot blowers, either steam soot blower or sonic horn. Sonic horn is very easy because it is runs automatically, but in steam soot blower, people have to go there and operate that. And during operation also there is a chance of lot of water and it can damage your tubes, puncture your tubes. So, if you operate steam soot blowers, then be careful. If you operate sonic horn, then there is a possibility that you can reduce your stack temperature. Still, if your temperature is not reduced considerably, then you can increase your boiler economizer bank heat transfer surface area improvement. Like put one module of economizer if there is space. Or see if you can increase the heat transfer surface area of your air preheater or anywhere you can increase heat transfer surface area. By absorbing more heat in the economizer, your stack temperature will be reduced and you can save 1% energy at least by reducing 22 degrees centigrade. Now second point, a 15% reduction in excess air will increase boiler efficiency by 1% if it is excess air is much more. So 30% excess air is okay. But if it is 50%, 45% excess air for ABC boiler, then we have possibility to reduce the excess air. For that, we must have O2 analyzer, oxygen analyzer, so that we can measure the O2, whether it is 3% or 4%. If it is too high, then your excess air is too much. If it is too low, then there will be too much unburned carbon. So we have to see unburned carbon should not be too high and excess air also should not be too high. By that method, we can tune the oxygen percentage and save energy. Now, third point, for every 6 degrees centigrade rise in feed water temperature, increase boiler efficiency by 1%. Means say your feed water temperature is 90 degrees C. Means it is too low. At least your feed water temperature should be 105 degrees centigrade for thermal deaeration. Even 105 degrees centigrade, what is your design deaerator temperature? It must be 120 C or something like that, but you are maintaining much lower temperature than design. So, instead of 105, if you maintain 120, then you can increase efficiency, at least 2%. If you have HP heater, then you can increase the feed water temperature much more. But it depends on design. But whatever is design, you must maintain the design condition. Means it is designed for your deaerator for 120 degrees centigrade, then most of the people maintain 100 degree, 103 degree. That is wastage of energy, that is loss of energy. We have to remember these 3 points. Then fourth point, fuel additive. Fuel additive means for coal-fired boiler, we can add fuel additive. You can see in Google, so there is a lot of company who supply fuel additive. And every fuel additive has potential to have a payback period. Even you can buy fuel additive from a very small party, still that money spent on fuel additive is going to pay you back. That is sure. Means what the fuel additive does in the boiler, it improves the combustion process. Means your combustion will be better, your LOI will be low, your unburned carbon will be low, and your boiler efficiency will be better. So through proper fuel additive, we can increase the boiler efficiency by 2%. This is the diagram of a fuel additive system. So 24 hours it goes to boiler combustor slowly. For example, in turbine also, every 10 degrees centigrade reduction in exhaust temperature increase the turbine efficiency by 1%. Say what is your condenser temperature? Means vacuum. It depends on vacuum. Say condenser temperature is a 60 degree. But in your design condition it is 45 degree or 48 degree. Means there is a lot of possibility. You can reduce temperature by 12 degree. So how to reduce the temperature? So many reasons is there. Maybe that is deposit in your steam turbine blades. That area to be taken into account. Maybe your condenser is jammed, or air cooled condenser if it is there, then there is jamming in fields. So you can foam cleaning of air cooled condenser can increase condenser efficiency. Even foam cleaning or acid cleaning of surface condenser can clean the heat transfer surface area. Then your grid blasting your turbine rotor. Means your system must be clean so that you can get the desired efficiency. Your motive purpose is to achieve the design conditions so that you can achieve the maximum efficiency possible. Then point number 6 and 7, similar soot blowing, means steam soot blower versus sonic soot blower. How many people have sonic horn in your boiler? Could you please hands up? Even 4-5% have sonic horn sonic soot blower in your boiler. Earlier, sonic horn were used in only biomass boiler. Biomass is not a new concept. Biomass is very old concept. Even in 2008, I worked in a 10 megawatt biomass plant in Kota. That is mustard husk fired and soybean husk fired. So during 2008, soot deposit was so high. Even in 50-20 days, its superheater was getting jammed. And we installed sonic horn, and we could able to operate 2 months without stopping that boiler. So earlier in small boiler, wasted boiler, biogas boiler, sonic horn were used. Then AFBC boiler people tried to use that. In AFBC boiler, a lot of people use. Even in our CFBC boiler, that is 150 TPH boiler, we don't have a single steam soot blower. All blower are sonic horn. And we have no deposit, non-stop we run the boiler for 6 months. And our SPM is always less than 30. We have ammonia dosing system, and our ammonia is within norm. And SOx, since we use more than 50% dollar, our SOx is always less than norm. So all the parameters are maintained, only we use 30% coal. Others are either kiln, DRI means dollar or S. Still we able to maintain the norm. But it is due to sonic horn. So many sonic horn is there, even in economizer, even AFB heater, superheater, even in ESP also, ESP initial stage. So you just search in Google what is sonic horn and visit some plant and see. Cost of sonic horn is 1 lakh per piece. Then your steam soot blower 5 lakh. Maintenance too high for steam soot blower. And operation cost only 5% of steam soot blower. Maximum 5% of steam soot blower. And as far as operation friendly, no need to go to check the sonic horn. Even 1 round in a day or 2 days, that is enough. But for steam soot blower, we must have a dedicated team to operate that steam soot blower. Okay. Then insulation is very important aspect. Even 1 to 2% of your loss is due to insulation. Poor insulation causes too much losses. Then manage boiler load. Too much load, overloading of boiler and underloading of boiler also reduce efficiency. Your loading should be 80-85% to achieve good efficiency. Of course, it depends on design and trial and error method. You have to check at what point you are getting maximum efficiency. Then measure and manage. Means if you can't measure, then you can't manage. We must have to measure, like O2. How much O2 before APH, after APH. So that you can able to know if there is any leakage in APH. Otherwise you can't. If you have no meter, then you can't measure. So everywhere you should have meter. First thing is to measure. Without measure, we can't manage. Number one thing, we must have to measure. Everything you must have to measure and log. Then only you can manage. Then comes your KPI. For KPI, you see your past data, what is your performance, see your competitors, what is their performance, see your industry standard, then design KPI.
Now finish first.
Design KPI and fix the target and try to achieve target. That is possible only if you measure and manage. Only if you measure. If you do not measure, then how can you manage the KPI? How can you maintain the KPI? Then there is so many points, 51 points, but these are the important points I have covered. And some important things like Kaizen means change for improvement. Your team should make Kaizen, means Kai means change, Zen, change for improvement. Small change, and you should involve all your team members. and your KPI board should be displayed in a whiteboard, not by manager and in a computer. Because if your team involves, then only you will perform. Otherwise, only in the morning session, people are telling only 1 or 2% perform. 98% of people are just coming to plan and going or doing a little job. They are not doing their 100%. They are not giving their 100%. So, your KPI board should be in a whiteboard, and all team member up to operator, boiler attendant should involve in KPI. Then only we can improve. Thank you very much.
Thank you, Mr. Aswin. Now I would like to invite Mr. Sai Kumar of ONGC for corporate presentation.
Good evening, everyone. Myself, I am Sai Kumar, representing ONGC Hajira plant. Thank you, Saket Events and organizers, that ONGC is being a part of this Steamtech. I am going to give a corporate presentation on ONGC and ONGC Hajira plant. Presentation overview, I am going to give you introduction and plant overview, process flow, power generation and distribution, steam generation, energy consumption, and we are having a goals to achieve net zero, and we are having new projects. First, I am going to introduce ONGC to have a vision of ONGC to be a global leader in the integrated energy business through knowledge excellence, governance practices, and the mission is to be a world-class company and integrated in energy business, dominant Indian leadership in petroleum sector, and enhance India's energy availability, and we are enhancing to have a carbon neutrality in our ONGC active chain. Presently, India's renewable energy goals are like government targets almost 50% of renewable energy target by 2030 by installing a 450 gigawatt capacity, for which ONGC is also having a goals. At present, ONGC having a renewable capacity of 193 megawatt, both including wind and solar. And present power arrangements are with, like, primarily we are generating power from fossil fuels like natural gas, and secondarily from RE power, and we have some grid connected powers through DISCOMs. And ONGC is aiming to have a net zero emissions by 2038 with the help of Scope 1 and Scope 2. I am going to give an overview of Hajira plant. Hajira plant is set up in 1985, and it is one of the largest gas processing complex in India. Presently, our capacity is of 52 MMSCMD and liquid processing of 9,500 metric cube per day. We are receiving sour gas from offshore, where we receive it from gas terminal, where we process the gas and we will ultimately market to GAIL, and we also have value-added products for which we will be having a marketing section. And we have additionally captive power plant for power and steam consumption inside our plant. Firstly, our offshore gas will receive at gas terminal, where gas and liquid will be separated at gas terminal, further which we will be having a gas sweetening unit where the sour gas will be removed from sourness and it will convert to sweet. Next, it will go to, sour gas will go to sulfur recovery unit where sulfur will be separated. Next, it will go for gas dehydration unit where dehydration process will occur, and after which deputy depression unit, where our gas will go to lower temperatures and we will connect to our GAIL pipeline. And the liquid part, where we have condensate fractionation unit, where we will be recovering natural gas liquid to convert our value added products like naphtha, kerosene, diesel, ATF, etc. And all these products, we have LPG as well. In our LPG plant, we will be having propane and butane, and rest of the sweet gas will be sent to GAIL. And we have customers like Kripco, and we have internal setup for gas consumption as well. And we have product terminal and product storage, where the products will be stored, and the terminal is used for domestic supply. We have a power generation setup where we have 4 GTs and 2 solar power plants of 10 megawatt and 5 megawatt, total 15 megawatt capacity. And all the GTs, GT1, 2, 3 are of frame 5 and 20 megawatt each. And GT4 along with STG we have 51 megawatt capacity, and which is under advanced stage of commissioning. This is our distribution. Present generation from gas turbines is 60 megawatt, and solar will be peak around 10 megawatt, total 70 megawatt, out of which 32 megawatt will be used for Hazira plant, 28 megawatt is being willed to our ONGC assets in Gujarat, and 10 megawatt we are selling to IEX. Coming to steam generation, we have around 6 boilers, out of which 3 number HRSG heat recovery steam generators are being used from GT exhaust, where we are producing steam, and we have 3 gas-fired boilers, KT, IVL and Thermax, where IVL is our HP boiler, Thermax is our MP boiler, KT is a dual drum boiler. It is our company's philosophy, like we are generating steam, most of the steam from HRSGs to extract heat from gas, GT exhaust, and only 35% is being produced from gas-fired boilers. And based on which our exhaust utilization, our efficiency of gas turbine is also improving, and it is around 75%, whereas gas turbine efficiency for an open cycle will be around 25% only. In our plant, based on energy consumption, when we consider only power and steam, out of total energy consumption, steam consumption is around 83% and power consumption is around only 13%. This is a typical flow diagram of our heat recovery steam generator, where we are using the exhaust gases from gas turbine, and it is being through diverted damper and gulleton damper, where next we have HP drum, LP drum, economizer and water preheater, where after which the exhaust will be going through chimney, where we are releasing only 90 degrees there. Upcoming new projects in our ONGC and Hazira plant are like, we are replacing old gas-fired boilers like KTI and Thermax, IAC boilers with new gas-fired boilers, each of 50 ton per hour, for which tender will be floated in few months. We are going to have a rate contract for reduction of steam losses, and we have a 10 megawatt floating solar power plant, which the tender will be floated in few months. We are going to have a new RO plant, and we are also having revamping of heat recovery steam generators also. Actually, Indian government has set a target to achieve net zero emissions by 2070, for which ONGC, being an energy company, also set a target, recognizing the importance of environmental sustainability and governance, to reduce emissions by 2038 with the help of Scope 1 and Scope 2. Scope 1 is directly emitting, where we are burning gas in our power generation units, gas-fired boilers, furnaces, etc. Where Scope 2 emissions are like, we are receiving grid power from DISCOMs, where we are also a part of emitting CO2 emissions, for which ONGC has set a goals to achieve emissions by 2038. It is being a part of net zero emissions, ONGC also floated a tender of 1 gigawatt hybrid RE power, for which the tender was floated on 12th August 2024, for which the same is available in ONGC e-tenders. So newly formed ONGC Green Limited company will execute this project. Expected date of this completion of this project is around 6 years. And finally, I want to acknowledge Deputy Director of Boilers, ED Plant Manager, GGM Head Maintenance, Area Manager Cogen. Thank you being a part of Steamtech.
Thank you, Mr. Sai Kumar. So now I conclude this session with the great very knowledgeable, I think so. Mr. Ketan Upadhyay has covered many things on the benefit of online monitoring and costing for boiler systems, scale and corrosion effectiveness and boiler, and introduction on NDT usefulness in the for the boiler material and benefits. Secondly, Mr. Dhruval also covered steam and condensate data performance, benchmarking with respect to running parameters, and boiler fuel saving and efficiency improvement with examples. Lastly, Mr. Ashwin Misra also highlighted about the waste heat recovery by sponge iron and carbon black plants, ways for boiler efficiency improvement, and mainly use of sonic soot blowing system for the boiler reduction in downtime. And Mr. Sai Kumar also introduced about the ONGC Hajira plant and future planning of the ONGC project. With this, I thank you very much for all of you to listen this session, and thank you very much.
Thank you so much, sir. Now we are having a refreshment break of 20 minutes. We will be right back here after 20 minutes.
Actually, we do not want to break. However, the break is necessary only if you want tea. Because after 5 o'clock it is going to be very difficult to have tea, because they have a kitchen for 500 people here. So only if you want tea we will break. Otherwise, if you all can continue, I think we can continue. 5 minute no break to leva hi nahi. What do you say? I think we should continue, right? We should continue. Thank you. So please be seated while we change the dais, and we will continue the session so that we finish on time. Thank you very much.